Hi, this is another short test based on numbers and operations, um, about 30 marks worth. Right, so let's delve right into the first question. You have got an investment here of 8,300, and this is compounded annually at 5%. So if you have to find the value of that, so the whole value of that would be that investment, then 1 plus the rate, and that goes for 3 years. So this obviously comes from the formula A equals to P 1 plus R upon 100 and raised to the N or T. Okay, so that's the formula essentially for compound interest. Right, you grab the calculator and then you can sort of calculate this. So this is 8,300, and then you have 1 plus. There are many ways you can do this, but of course if you have the formula, then you can just go ahead and use the formula, and you find that answer, of course, 9608. So it's 9608.2875. So it's money. I'd rather say, let's put it two decimal places. That will be 29. Of course, anything around into three significant figures, that since there is 100 cents in a dollar, I will give it to two decimal places. But from three significant figures and upwards, the answer will be accepted. James won 75,000 Namibian dollars in the lottery. He divides his winnings in that ratio of 3:2. He uses a smaller amount as a deposit on a car. So the smaller one would be then 2 parts out of the 5. Okay, for you to find out how much is he definitely using. Of course, that is 2 over 5 times 75,000. Of course, if you go ahead and calculate that, that gives you $30,000. Right, so that's the smaller part. The rest is going to invest at simple interest at 5.5%. Okay, so we'll come back to the rest. Okay, maybe I can just write it here so you can see. We're going to use it somewhere. So the rest of the money, or whatever is left after the deposit of the car from the 75,000, of course, what is left will be 45,000. It will be 45,000. This is what's going to be left. Okay, we're going to use it later. The deposit he paid on the car was 15% of the value of the car. All right, it was 50% of the value of the car. So 15% is equal to the deposit, which is 30,000. So what would be the initial value of the car? So we know it's 200,000, but we are given, so we have to use this sort of method here in order for us to prove that the x there should be 200k. So this is reverse percentage, and you can cross multiply. That's going to leave you with 15x is equal to 100 times 30,000. Then you go ahead and you divide throughout by 15. Can you see where the reverse is coming in? Because we are looking for an amount that is essentially bigger. So the numerator is always 100, but it should be an improper fraction. Of course, if you do that, you're going to get 200,000, which was a requirement. Okay. However, you're not going to get the mark there. The mark is most probably going to come from this methods over here. Okay. Let's go to the C part. James must pay $4,550 a month for 54 months. Okay. For the car. Calculate the total amount he will pay for the car. Now, what do we know? We know he paid a deposit of 30,000 from our previous work. Okay, he paid a deposit of 30,000, so that could be seen at part A, deposit of the car. And then on top of that, that's a down payment. So on top of that down payment, he must pay 4,550 for 54 months, which is like a 4.5 years. So 54 months times 4,550. So this would be the amount initial that he's going to pay for the car. So you can just grab and punch everything as it is on your calculator. So it's 30,000. Then you plus 54 times. Calculator has got built-in direct algebraic logic or BODMAS, so there's no need for you to write things separately. If you have a scientific calculator, the answer is 275,700. Okay, 275,700. Okay, cars are expensive. Anyway, let's go to D. They say calculate the percentage increase in the price of the car. The percentage increase. So the car initially cost, okay, 200,000. Yeah, the value of the car was 200,000, and then because he's buying the car through this means where he pays it on a monthly basis, so we're going to find out what is the actual difference between 200,000 and 275,700. If you do that difference, and that is going to give you 75,700. So when you take that and you put it over the original, you're going to find the percentage increase. That is going to be 75,700. Then you put it all over the original amount, how much the car costs, essentially multiply that stuff by 100. So let's see what is that going to give us. So it's 75K, 75,700 upon 200,000. And you multiply your answer by 100. Of course, that is 37.85%. So 37.85%. Anything around it to that. Then calculate the interest he'll receive from his investment. So we need to go back and find out how much money does he have left. So he had $45,000 left. And if we are now looking at he invests this money, and how does he invest this money? Well, he invests this money directly using simple interest. Just go back to that story for us to find. It says that he uses the smaller amount, which is that 45,000K that I said we're going to come back, as a deposit of car. He invests the rest in a bank at simple interest of 5.5%. So simple interest of 5.5%, so that's going to take me back. I'm going to use my simple interest formula. So that simple interest is that 45,000 investment multiplied by the rate. The rate happens to be 5.5%. Then you multiply that by the years, which is 1.5. So all in all, you punch that into your calculator, you should get $3,712.50. That is the interest that he will receive. Question 4, strawberries cost $4.20 per kilogram and cream costs $8.56 per liter. Venus buys 1.2 kilograms of strawberries and 125 milliliters of cream. Look at the total cost. The problem here is this is in milliliters, and that cost there is divided into liters. So you know that 1 liter is equal to 1,000 milliliter. Therefore, 125 milliliter, you're gonna divide it by 1,000. That's going to give you 0.125 liters. So my total cost is going to be that $4.20 times the 1.2, then $8.56 times the liters. Okay, so just gonna punch in the values here. That is 1.2, and here is obviously 0.125. That's where the whole trick of everything was. Okay, that is the final answer. $6.11. Ravi has $20. A pineapple costs $1.45. Work out the largest number of pineapples. So you simply take the 20 and you divide it by 1.45. Of course, you're going to get a decimal value of about, if you have to do it, you're going to say, okay, wait a minute. So take that 20, you divide it by $1.45. That gives you about 13.79, stuff like that. Okay, some whole recurring thing. And in the case that this is the issue, it's about 13 point, let's grab that calculator again, 79, and so on and so on. But the whole number that a person can actually just use is just 13. So largest number of pineapples can buy, the largest number of pineapples will just be 13. Okay, not 13.7. There's no 13.7. You don't round that question. Now, taking that into account, he pays obviously with a $20 note. So you take that $20 minus. If you look at the 13 that he has, and if supposedly he multiplies that by 1.45 for you to see how much change he gets, okay, and then he's going to get a change of nothing but $1.15. Abraham has a box of 72 biscuits. He gives 2 nines of the biscuits to his grandmother, so you can say 2 nines of 72. 2 nines of 72. That is probably going to be something like 60. So this goes to Granny. And then what is next person? The cousin. Your cousin gets 3 sevens, but of what is left. Now, what is left? He had 72, take away 16. So what is left will be 56. So the cousin, so the cousin will get 3 sevenths of whatever is left. So the cousin gets nothing but 24. Okay, cousin gets 24. Now, the question is asking, work out how many biscuits has now. So the biscuits left after he gave away would be 72 minus 56 minus 24. And he's going to be left with 32. Of course, there's another shorter way of calculating this, and perhaps I'll just write it there. So you can also work out and say, okay, wait a minute. There's another way. What if you just say 2 over 9, 2 over 9. Let's say we take the not 2 over 9 rather. Let's say we take 7 over 9. Now, if I take 7 over 9, remember, 2 over 9 he gives away. So what is left is just going to be, to make that fraction 9 over 9, which is 1, so what is left is 7 over 9. Then he also gives out, he also gives away 3 over 7. So what will be left to make that 7 out of 7 will be 4 over 7. And if you were to multiply this directly, this fraction directly with 72, it's going to give you the stuff that is left. And you'll get the same answer. So let me just show you that. So take what is left times left in terms of fractions. So we're going to say 7 over 9. Multiply that by 4 over 7. And multiply that by 72. Obviously, 32 is left. Of course, there's also one way you can do it. Right. Florence makes 84 cakes. She sells 35 of these cakes. Calculate the percentage of the cakes that she sells. So she made 35. She sells 35 out of 84. Okay. And then the percentage of the cakes that she sells, so just simply multiply, put that over the 84 and multiply that by 100. Of course, your answer will be 41 2/3. Okay, or 41.7, you round it to 3 significant figures. Good, let's go to E. A bag contains 132 sweets. The sweets are shared between Beatrix and Valerie in the ratio Beatrix to Valerie, which is 5 to 7. So work out the number of sweets they each receives. Now this is really easy. You get to add the parts, and then you'll say, okay, wait a minute, this is going to be 5 plus 7, which means everything essentially is out of 12. Beatrix is going to get 5 out of the 12 parts of the 132, and Valerie is going to get the rest 7 out of the 12 of the 132. Okay, so you go ahead and you multiply that. That is going to be 55 for Beatrix, and this is going to be 77 over here. And then you can do that. Okay, there are many ways, but this is by far one of the straightforward methods you can do this. Then we come to Jeff. Jeff sells desserts for $24 each, and each cost $12.80. So what would be his percentage profit? So his percentage profit essentially would be the difference of that selling minus that what the items cost him, because that's how he makes a profit. 24 minus the 12.8. Always put this stuff over the original amount. How much did the items cost? And then you multiply that by 100. Okay, so when we plug it in, it's just a matter of doing the right thing, finding that difference, which is 24 minus 12.8. Put that upon 12.8, always put it over the original amount, and then you multiply the number by 100, and that gives you 87.5%. So 87.5% is then the required answer. Now when we come to Roman 2, which is our last answer question there, the cost to make each dessert increases to $13.60. Jeff wants to make the same percentage profit, work out a new selling price. So having said that, so this is a issue that you need to understand. He makes a profit. In order for you to make a profit, you have to consider that the percentage profit that we're dealing with was 87.5%. So for the person to make a profit, you will say 100% plus that 87.5% that we calculated before. That gives you 187.5%. That 187.5% is equivalent to, because it's a profit, 187.5% will be equivalent to the $13, because that is what it's increasing to, $13.60. So we need to find that amount that that person now is, no, that's not the correct comparison. So the only straightforward, after we calculated the 187%, we're just going to say 187.5%. 187.5%, that's how you write it. You multiply that by $13.60 for you to find out the new selling price. The new selling price has to be bigger than that. That's why you need to multiply by an improper fraction. That is why you had to add the 87.5 there. Okay. So if we do that, that's going to give us our answer. Let us see what the selling price is. So 187.5%. We multiply that obviously with $13.60, so just 13.6. Of course, you get $25.50. So it's $25.50. All right. So yeah, again, as I said, it was a very quick test. Of course, you can always pause it and make sure that you do understand the questions.